We will now explain the definition of base table and extended table. These are two very simple concepts which should be clear because they are regularly applied throughout the overall use of the tool. Now let's take a look at the Tables node. Under this node, we can see which physical tables GeneXus has determined to be created in the database, based on the structures of the transactions we defined. If, for example, we open the category table, we will see that the physical table contains exactly the same attributes defined in the structure of the category transaction. However, if we open the composition of the attraction table, we will see that it contains fewer attributes than those referred in the attraction transaction. This is because there are several foreign keys in the attraction transaction, and thus, through them, there are values of attributes that we obtain when the application is executed, from the tables where they are located. We can also see that under the Tables node, there is a table called Country City. This physical table was created by GeneXus in the database, upon the definition of the second level we did in the country transaction. As we saw before, when we define a nested level to another in a transaction, a compound key table is created, which in this case is the Country City table. So, we have seen the Tables node, under which we can see the physical tables created in the database and their composition. We will now see that we can create a table diagram to view them on a scheme showing, in addition to their composition, how they relate with one another. For this we select File, New, Object. We choose to create an object of the diagram type and leave the name proposed by default, Diagram 1. We select Create and drag all the tables from the Tables node to the diagram. Now, we right-click on the mouse and select Arrange Nodes. This is to distribute the tables on the diagram and to make the arrows representing their interrelations clearly visible. Considering this table diagram, we will explain what we call base table and what we call extended table in GeneXus. We call a base table any table from the database where we are positioned at a certain time, for example, for deploying or modifying its data. It could be this one, or this one, or any of the tables in the diagram. When we execute a transaction with a single level, it will have one associated base table. That is to say, a physical table where the insertions, modifications, and deletions that we operate, like for example interactively through the transaction screen, take place. When we work with a transaction with more than one level, each level will have an associated base table, where the insertions, modifications, and deletions that we process through that level take place. Also, when we define queries, a listing for instance, we will be navigating a specific base table. The base table is then any physical table in the database where we are positioned and working at a certain time. Now let's look at the extended table concept. This concept is meant to simplify the way to find out which are the tables we have access to when we are positioned in a specific base table. Intuitively, we've already accessed the extended table of a certain base table. For example, the attraction transactions base table, or associated physical table, is the attraction table. And as we saw before, because category ID is a foreign key attribute in the attraction transaction, we can then reference the category name attribute. Category name does not belong to the base table associated with the attraction transaction, but we can obtain its value, since we have it in the extended table. In general, and based on a foreign key, like category ID, country ID, and city ID in attraction, we can always obtain the values of its secondary attributes from the tables where they are located. And if those tables also include another or other foreign keys, then the chain goes on, and we can obtain their related data as well. Having intuitively comprehended the concept, we can formally state that upon any given table that we consider base table at a certain time, its extended table is the total of all the attributes of the base table itself, plus all the attributes of the tables directly or indirectly related to it through an N1 relation. If we now take another look at the table diagram we had created, we will see another way of determining the extended table of a specific base table. If we take attraction as base table, its extended table comprises the attraction table itself, and, following the double arrow, we will see that the category is also included. On the other side, there is a double arrow indicating that country city is also included. And from country city, there is a double arrow, meaning that country also belongs to the extended table of the attraction-based table. Thus, looking at a table diagram, in order to obtain the extended table of a specific base table, we can follow the arrows with the double pointer coming from it and with a single pointer at the other end, and the table we arrive at will also be part of its extended table. And all the tables to which we may arrive by following double arrows will also be part of the extended table. In sum, we will be navigating in the direction of the n-to-1 relations. If we go back to the diagram, we can see that if country city is the base table on which we are located at a certain time, its extended table includes itself and the country table only. And given the country base table, we can see that its extended table comprises only itself, because it does not have any double arrow we could follow.